Hi, this is Bill Foote, and this is Principles of Microeconomics. And we're doing a problem from Paul Krugman and Robin Wells's book. Uh, should be in the fourth chapter, number 12. Let's work it out. And it's about taxi rides, yellow cabs in mostly Manhattan. We'll take it as Manhattan. Initial equilibrium in this particular case, let me draw this here. We have Q on the horizontal axis, which is millions, millions and millions of miles. And on a vertical axis, we have price, which is dollars per a single mile. That'll be the price. We're working in the positive orthant. That's really old language for everything is on the positive side of this graph. There's nothing over here or over here on the graph. That could change in the future, but we'll just leave it like this. No negative prices, except at Messina, New York, with excess supply conditions of electricity. And we're going to start with a maximum price per mile that consumers want. There we go. And that reaches down to 1.2 million. We'll 1,200 here. And these are in just a large number of miles. I don't think these are million, but it's a lot of miles. Okay. And that's our demand curve. That's our initial demand curve that we'll label D0. And over here on the, again, the vertical axis, we're going to put the minimum acceptable price that suppliers are willing to uphold. We'll call that S0. And this is our initial or base case. Okay. Now we can see that very clearly that if and when uh, supply equals demand across all the different rides that go on, there's some point in the middle where they kind of agree and they kind of settle on. And this thing could bounce around like a yo-yo, and it does. But we'll just throw everything into a pot right now and say, at this instant, they are equal somewhere. Okay, so we put that over here like this. And it turns out that the answer is 600 miles of ride, million miles, and a $2.50 average price per ride. So that's the initial situation, very clear cut, uh, no problem. But if we wanted to do this a little bit more analytically, which is not terribly hard to do, we might do the following. We might ask the question, what is the demand? Well, the demand, we use a y equals mx plus b piece of technology we learned in elementary algebra, where b is the intercept. The intercept here, mathematically, yes, that's where the demand curve crosses the y-axis, but it's actually the maximum price anybody be willing to pay for going 0 miles technically. So just willingly suspend your disbelief a little bit in some of the language that we're using. Okay. The slope of this, so we have b is 5. Now the slope is going to be the rise over the run. We can do this as we can go from 0 to 5 in order to get 0 to 12, but basically the slope is going to be a negative 5 over 1200. Now, we're not going to be mathematicians here. Please use your intuition to see it's downward sloping. We, when we give up price, we increase miles of rides. That's what the minus sign means. So we have, in the base case, demand is such that price equals 5 minus 5 over 1200, and that's times Q. Okay, so we got that. Now, supply, that's D0. Supply is very, very similar, but here we're going from 0.5. We know what the B, the intercept is, the minimum acceptable, and so we can write that in here now. .5. We can see it's a positive slope. Let's put a plus sign in there. And the ratio we're dealing with here is 600. And what's the difference between 250 and 50? That's the rise over the run. That's, just put a little $2 there. And the run is 600 there, just to mark it. And that would be equal to 2 over 600, which is the same as divide both sides by up and down by 2. Anything times 1 is 1, and anything 2 over 2 is 1. Anything times 1 is itself. But okay, remember that. That's 1 over 300. Doing it the hard way. Our job now is to set the two equal to one another, because that's the idea here, where in economist land, mainstream economist land, supply equals demand, at least instantaneously. Have you ever balanced a pole on your palm of your hand? It's pretty easy. You can shift back and forth, but that thing, for me, will always topple. Okay, the equilibrium might be a little bit unstable. It's New York, after all, that we're modeling here. So let's put this down here. We have demand 0 equals supply 0. And this is always the first step. We'll label that a 1. Find the equilibrium, this equilibrium 600 and 250 that we've been touting here. Supply is equals demand. We equate the prices, so that is our equating point. And so we have 5 minus 5 over 1200. Q equals 0.5. And if this is like watching paint dry, well, it's the ink's dry. How's that? Okay, you're right. 1 over 300 times Q. And we're going to be solving this for Q. How do we do that? Well, we can do a number of things here. We can first of all eliminate this, subtract both sides by 0.05, okay, and that means that this will be 0 plus 1 over 300 times Q equal, whatever you do to one side, you always have to do to the other. So that should be what, 450? Okay, minus 5 over 1200 Q. Okay, and now we're going to add over 1200 Q to both sides. And we will clear this market. And of course, now we have 450 here. That remains. Equals, well, let's just do this up here. You can take Q out of both of these and combine 1 over 300 plus 5 over 1200 times Q. If we again take common denominator of 1200, 1 over 300, okay, we can multiply both sides by what? 4. Okay. 1 over 300 times 4 over 4. Again, anything times 1 is itself. And that's equal to 4 over 1200. And then pop that back in, and we get 4 over 1200 plus 5 over 1200. Okay. And that means 9 over 1200 times Q. So we did all that operation. Bring that over here. 9 over 1200 Q. And finally, no, almost finally, we can then divide both sides by 9, or times 1/9. 9 into 45 goes 5, and that leaves us with 0.5 equals 1 over, because a 9 over 9 is equal to 1 again. 1200 Q, and now multiply both sides by 1200. You can almost do this in your head, but, you know, don't skip any steps at this point. And what do you get? You get Q, we'll call this Q star, equals 600. Okay, so we got that number. Very nice, good work. Okay, so this is just step 1, a little bit of algebra, but going through excruciatingly all the different steps. Now, how do we find the price? Well, we can pop this into this result, 600, into supply, 0.5 plus 1 over 300, which is the slope, times 600. A result for, so find the price at which Q equals 600, and we get 0.50. Now 300 into 600 goes into it nice and cleanly. Thank you, Paul and Robin. And we get P star equals what? 250. So got that as well. So now we have figured out the market equilibrium. Well, this is what Joan Robinson, the quite infamous and often notorious rebel economist, calls a tranquility point. Right? Not harmony, but tranquility. It's a peaceful place where things kind of settle for half a second. Okay, so I am very happy that we have that first piece. Now, what's the second piece? Well, that's part A. Good. Well, let's let part A here. Now, the second piece, part B of this, is we have Uber comes into the market, able to convince everybody but their convincing is very interesting in the actual case, and you can read all about it. But what happened was they made a deal with the Taxi and Limousine Commission, who's the regulator, and that's going to come up in Part C. And basically, they have to be all TLC limos to be an Uber driver, other conditions as well. But Uber comes in and takes up 30% of the taxi market. And what does that mean in this case? Well, very simply, if your maximum price is $5, maximum price is $5, your maximum price now transforms to 30% of that. Rather, 30% of that is gone. There we go, times $5. And that equals $1.50. The infamous New York haircut. Well, this is also the same way as saying that the maximum price is now $5 minus $5 minus $1.50 equals $3.50. Okay, 70% of it. Okay, 30% of the market's taken away. We have a left shift at all prices. That means we take this whole D0 curve and move it to the left. Okay, and it's going to be somewhere around here and somewhere around here. I don't know if my drawing capabilities are going to work, but here it goes. Here's the new curve. Wow. Okay, so now we have a D1 curve. And the new equilibrium, in this particular case, the new equilibrium, we need to solve for that. You're getting a lot of practice solving for market clearing prices, at least in the moment, okay? Please. This is, again, Joan Robinson, The Tranquility Point, that she discusses to replace the jargon for an equilibrium. It's not quite an equilibrium. The chaos people like this too, and the complexity people like this too. So there we go. And this is 350 here. Mark that off. And we're not going to say it is an intercept mathematically, but from an economic point of view, it is now the new maximum price. Not 5. We're willing to go up to 5. Taxi kind of likes that. The owners, who will be producers, like that. And but we now have a new equilibrium. Okay, so let's work this one out. Now we still have a couple of other things to do. We need to compute CS, PS, consumer surplus, producer surplus, and total surplus. But I want to get to this new equilibrium because that seems to be the hardest thing for us to get to. Let's try to get there now. Okay, how do we do that? The new demand is equal to the old supply. The old supply remains 0.5 plus 1/300th of quantity. And the new demand is now 3.5 plus, now the demand rise over run has not changed a bit, and you can check that out. You can check out, for example, I believe, but you need to check it, that demand ends up at a zero price being no more than 800. People just can't ride around all day. There's only so many people, so many hours, and so much need. Okay, 800 is the absolute max there. And we need a negative here. So it's 5/12 hundredths, okay, times Q. We go through exactly the same sort of rigmarole here. Okay, now it's 450 out of that is $3. And I'm going to add 5/12 hundredths to 1/300th. And let's see if I can do that. And we're still going to get 9, like before, 12/100ths. Okay, I've skipped all of these steps because they're basically the same except for the 350. Okay, that's about it. And divide both sides by 9. It's not too hard to do. And so if we multiply this times 1200 over 9, 9 over 1200 times 1200 over 9 is all gets to 1 times itself. We get a quantity equal so far to 3 times 1200 divided by 9. And 3 into 1200 is what? 400. So this is now 400 over here in our graph. That's the new one. So that's Q0. We call that 0 with a star. And now we go to Q1, 1 with a star. We're going to do one more out of this. Okay, one more out of this. And here too, we need to compute CS, PS, and TS. Okay. Okay, let's do that right now and see where we go from there. Now, as we continue this story, let's remember that we're doing triangles here. Here's the initial triangle for consumer surplus. This is going to change. And then we have an initial triangle for the producers. I mean, who's producing this? The taxi people. Now, the taxi people, the production surplus, which is that lower triangle, will be distributed to owners and drivers. And usually it's a 70-30 split in favor of owners, or 60-40 in my time. But just keep that in the back of your mind, okay, as we continue this. So let me get my glasses on here and see what we're doing with CS, which is 1/2 of the base times the height. Okay, and then the base here is 600. And the height is the difference between $5, the maximum somebody's willing to pay, and the equilibrium, the market clearing price. And that's the idea behind this. And the producer surplus is 1/2, same 600, same base. And now we just bring that 250 down. Difference between 250 and 0.50. Okay, so we have 2 things to worry about there. There we go. And I think we got that. And the total will be the total. So what does this work out to? 1/2 600 times 250. And that's 1/2 600 times 2. Well, that's the easier one to do. Half of 12. 2's cancel out. That's equal to 600. And the other one works out to 750. Total of 1350. Okay. So that's the base case. And the idea behind this is some idea of welfare. Well, where welfare in economics means flourishing. This is only economic flourishing, though, so get that. Now, similarly, at the new equilibrium, let me get a Sharpie for this. Sorts of Sharpies here to play with. Let's use a very mild. Yeah, we'll use this one. There we go. Just to mark it off. And that one is going to go from here down to here at the 400, and we haven't finished this job yet. And that will be the new one that we have to compute. Now, we have to compute yet the equilibrium price for the Uber expansion. We know that Q is 400. I just needed to take a break from this. All right. Now, P, the new price with the Uber, is going to be 0.5 plus 1/300 of 400. What's 3 into 400 plus 0.5 is what we need to have now. Turns out that 4 over 3, that's 400 over 300, which is the same as 4 over 3, is 1.33. Then if we add 0.50 to that, we get a grand total of 1.83. We'll just round it off to the nearest penny there. And round off will matter ultimately if this was in a computer program, but I'm not going to worry too much about that. So let's mark that over here. Okay, and let's compute those new consumer and producer surpluses. And it's, again, 2 triangles, which makes it fairly easy to do. And now we're dealing with a 400 base. That's the new base. And different heights as well. We're now going from 350 down to 183 for the consumer, and 1/2 of 400 again, moving from $1.83 all the way to the minimum of 0.50. Remember, we played around with this at some point in class, and we found out that 0.5 is not an unreasonable amount. Okay? Not an unreasonable amount. Let me move this over a tad. And if we finish this computation, we will find the following. We'll find 1/2 of 400 times 350 minus 183. I think that's $1.67 there. So let's compute that on the computer. This is all handheld right now. So 400 times 1.67. Oops. And this will happen on the exams, of course. 167 times 400. 668 divided by 2 gives me 334. And then 183 minus 0.5, that's $1.33 in between here and here. Let's just put that there quickly. Times 400 divided by 2 gives us 266. We add all of that up to 600. Now that's to be compared with 1350. So overall, the market loses, but it'll be gained by whatever happens in the Uber market. So the ride market is kind of a conservation law there, but it's also what we call nonlinear and complex, which means that Uber might be doing something different. All right, it might be higher or lower than this. The addition of these does not mean that it's the difference here is 750. Is that right? Yeah, 750 is Uber making that up in consumer and producer surplus? We don't know. Okay, that's a really good question. Now what happens is something very interesting. Now what happens, I think we need another color here. Let's see if I can find a color that will work for us now. Few to choose from. Let's use blue. Now the commission comes in and says, no, 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 we're going to make $2.50 the number. This is TLC making the pronouncement. They're going to make that the minimum per mile price. What happens then? We have a new triangle for the consumers. That's one. But what happens here is they have put a literal barrier into the whole thing now. So with that going on, what is the new barrier number? So we've had a 600, a 400, and now we have a new one. We know it's probably going to be like 200 something. Okay, well, we need to compute this number right here on this chart, and we also need to compute where that crosses over into the price region. What is the price at supply at that point? Now, under here, this is all consumer. That's consumer. That's going to be easy to compute. Okay, so this is part C of the problem. The TLC establishes a minimum price of $2.50. That's the old equilibrium. And you see how it makes things complicated. So how do we find that number for Q? Well, one way we can find it is figure out the $2.50 quantity on the new demand curve. Now the new demand curve is D1 equals 350. Oh, or price, I'm sorry. Just worry about that. Price equals 350 minus, 5/1200 times Q. And we need to find that Q for a price of $2.50. So we set $2.50 equals $3.50 minus 5/12 Q. Add 5/12 Q to both sides. And subtract. So we're going to add and subtract 250 from both sides. Okay, that's an equality so far. We can do that so far. So 250 and 250 is 0. We have 5/12 rather, times Q equals 350 minus 250 is what? Yep, $1. Okay. Multiply both sides by 1200. And divide both sides by 5. And we get a new Q equal to, lo and behold, dropping the pen there, the new one is going to be 240. Goes in cleanly. So we put 240 over here. Okay, because that's going to be our new base, our new base, our new base, and our new base. But we have a couple of interesting things going on. We have the triangle. Let's build that immediately. But we have one more thing to do. What is the price associated with that? And as you can see already, we're building up a square and another triangle. It's going to be a great big trapezoid of delicious welfare for the taxi riding and driving community. Let's see, at 240, oh, supply, we can use supply for this, can't we? Yeah, we can use supply for this. At this constant barrier, I mean, this is a very interesting idea, that no more than 240 can be riding in taxis because of this. That, I don't know if everybody likes that idea. Okay, so that's the economics now, and a regulator outside of the economics constraining the market. But let's put this 240 in up here. Price equals 0.5. We're still at 1/300. And now we have 240. So what's this giving us? 3 into 2.4 is 0.8. So this whole thing works out to 0.8, 80 cents. 80 cents and 50 cents gives us a price of $1.30. So now we have $1.30 to add to our long list of long-suffering everything there. And let's look at that next. And I think we can take all the rest of this technology, pop it here, and compute a new CS, a new TS, and then write a summary table. I'm sorry, PS and TS here. Now, the thing we got to point out here is, while this was consumer surplus, we now have two components geometrically for producer surplus. One is a square. Now remember, all of this is to the left of this hard vertical quantity line in which prices, you can raise and lower the price between $2.50 and $1.30, and nothing happens in that range. That's very inelastic. The quantity doesn't change. Max quantity here is 240. You had 1,200, 800, 600, 400, and it's going down, down, down. Let's compute this. Well, we have two regions for the producer. Okay, so let's get the consumer done here. And that's the difference between 350 and 250. And for the producer, we have two regions. One is a box. Let me put this over here. Okay. And the other is a triangle. And the box is at 130. I'm sorry, 250 at the top, 130 at the bottom, and 240 across. So that's going to be, very simply, no 1/2 anymore. It's a square. That's easy. The 240 remains the same. And the difference is between 250, same idea there, minus 130. And let's get rid of this here, plus another, the triangle, which goes all the way down to 0.5, just making a note down there. Okay, note to self. It's going to be still 1/2 of 240. And the difference between, the height is going to be between 130. Notice the cascading of these prices. Okay. Now we're going to put all of that together into one place. I'm going to say it's going to be equal something. So 240. So we put this over here. Use this. Again, just trying to think of how long this is going to take you and me. So that's 250 minus 130. That's 120 times 240 gives us 288. So we have 288 in the box, and the triangle is going to be 240 times 130 minus 0.5 divided by 2. Oops, not quite. Parentheses. And divided by 2. It's 96. And this is all producer surplus. And that's going to be a grand total, if I got my numbers correct, 376. You can check that out. If it's wrong, let me know and we will fix this. 240. Now this is just $1. So 240 times 1 divided by 2 is 240 divided by 2. I think everybody agrees that makes sense. It's a very small triangle up there. And when we add all of these together, We're getting 506. I don't know. Let me see. Let me see if I did all of this correctly. Always check your work. So we have 250 going down to 130. That's a price differential of $1.20 times the 240 base. And we get 288. I didn't quite get that right. That's 288. Okay, good. Always check your work. And let's check the 96 again. 240 times the difference between $1.30 and 0.5. Okay, that's 192 divided by 2, 96. So that still works out. So this works out to 288 plus 96. 6 and 8 is 4. Okay, here you go, 1, 17, 18. And that's 384. 4. Eight and 2 is 10, and 1, carry the 1, and we get 504. Okay, I think we got that in class. Please check it out. My arithmetic has never been terrifically good. There we go. Now we can see that. Now let's make a little table. With the base case, Uber, and TLC. TLC getting in the middle of this. We have CS, PS, and TS. Again, human flourishing in the taxi trade. So this works out to 750 here and 600 for a grand total of 1350. Uber here, 334, 266, and we get 600 here. TLC, complicated, isn't it? Yes, 120, 384, 504. So the TLC solution across the entire community is not very good, but the producers are going to love this. Whatever percentage they take from the fare box, it's going to be higher than the Uber case. Okay, so they're going to love this. But I think we need to put a very unhappy face for the consumers. Very unhappy face. Their consumer surplus is not great, not getting a great deal there. And that is the complete story. Wow, that's an awful lot. If we just add a few more computations to that, that is a big, long, involved problem. A lot of little computations. You can see how easy it is that the arithmetic can fail us. Once we get the idea down, we can argue our way through it. Remember that legal principle I told you about? Those who derive the benefit bear the cost. Yes, I love it. Does that fit here? Almost. Okay. But the story here for me is TLC intervening, and it's an intervention, okay, it's a political philosophy whether or not they should, if it's intervening or meddling, that's above the economist's pay grade. The economist definitely has to keep in track of that. And I think we have a good place to stop here. Remember to keep encouraging each other daily while it is still today. Okay, very important to do that. I hope this was of some help. And a picture of this will be available to whomever wants it as we go forward. And I got to use some Sharpies. Okay, till next time. Thanks, everybody.